Today we are going to measure the spore density or number of fungal spores in 1 ml spore suspension. For this purpose, what we will be needing is the pure fungal culture, a surgical blade, Appendorf tube, micropipettes of 2 measurements, 1 ml and 0.5 microliter. Then we will be needing a lactophenol cotton blue to stain the spores or to increase the visibility of the spore under the microscope. Then after making the spore suspension, we need an engraved slide which is known as hemocytometer. Now we will take 1 ml distilled water, 1 ml distilled water, and dispense it into another test tube, Appendorf tube. Now just grab the fungal spores and we will add them into the Appendorf tube. Before dispensing it onto the hemocytometer, we will homogenize the spore culture so that each and every part of the spore culture, spore suspension, it may contain equal number of spores. So you can see that it has been homogenized. Generally, we add the lactophenol cotton blue for the spores which are hyaline or they are not colored. But in this case, the spores are colored. We can use them as it is. But if the spores they are not colored, or we have to add the stain in it. But in this case, we are not going to add. Now, after homogenizing, again we will homogenize it. And we will take 10 microliter of spore suspension and dispense it on one of the counting region. Mix approximately 1 drop. We'll place it on the tabletop after patting so that the spores may get settled inside the small squares. So wait for about 1 to 2 minutes. After waiting a little while, we will place a cover slip on the counting region. Slowly, we'll drop the cover slip on it and we will observe it under the microscope. Now we will count the number of spores by observing it through the eyepieces. If you observe this engraved slide, there are 2 counting regions. One is, you can see this is engraved, the 2 counting region. One is here and 1 is here. So if I have already drawn these counting regions, these 1 and 2, the one counting region is drawn over here. There are 9 big squares, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 big squares, each having 1 mm width and 1 mm length. So this the middle one is again subdivided. All of them, they are subdivided into 5 sub-squares, and each smaller square is again subdivided into 16 small squares. So if you count the total number of these small squares, there are 25 small squares over here, 25 big squares, and each big square is again subdivided into 16 small squares. So total number of squares are 400. Now if we go back to the hemocytometer, I have already told you that this portion is engraved, and each small square, that is this small square, it has the depth of 0.1 mm. Its depth is 0.1 mm. Right? The depth of this one is equal to 0.11 mm. And the area of this small square is equal to 0.0025 mm square. Now we want to know that what is the volume or the capacity of this small cube. It is just like a cube. So the volume or capacity of this small cube, it is equal to, if we multiply, now you know the area is equal to length multiplied by breadth is equal to area. So the volume can be measured by multiplying the area with the depth. So if we multiply these both quantities, that is 0.1 multiplied by area, it is 0.0025 mm square. It will make 0.00025 millimeter cube. Mind, this quantity is in millimeter and this area is in millimeter square. So if you multiply the depth with the area, it will make 0.00025 millimeter cube. So the volume of the one small square is equal to 0.00025 millimeter cube. Now we will calculate the number of spores in small squares. While counting the spores in small square, we will take care that we are not going to count the spores which are touching the left border and the bottom border, but we will count the spores which are touching the top border and the right border of the square. So we will count. Let's count them. I have already numbered them in first square, that is the first square, 1, 2, 3, 4 and 5. So we will write 5 over here in the first square. Then we will count the number of spores in the second square, 1, 2, 3, 4 and 5. right? We write the 5 over here. In the third one, we will count, we will not count these two spores because we have already counted them in the square number 1. So, and also the bottom, 1, 2, 3, 4 and 5. So we have written it over here. Then 1, 2, 3, 4 and 5. We did not count it, this one, in the third square. So 1, 2, 3, 4 and 5. So we have to count, principally we have to count the 10 squares and then we will take the average. Let's take the average of these number of spores. 1, 2, 3, 4, 5, then 20 divided by 4 is equal to 5. This is a spores taking. What you will do is the actual one. So we know that the volume of this one small square is equal to 0.00025 millimeter cube. So what are the number of spores in one small square or one small box? You can say the number of spores in divided by its volume multiplied by 1 mil. That is the number of spores. Let's put the values over here. That is 0.00025 millimeter cube is the volume of this small cube, and the number of spore in small cube is 5 multiplied by 1 mil. Now what we are going to count is that number of spores in 1 mil. Now, you know this 1 mil can be converted in millimeter cube. How can we convert it? You might be knowing the dice of the Ludo which you generally play. So, if the length, width and height all are 1 centimeter, the volume of this cube is 1 centimeter multiplied by 1 length multiplied by width multiplied by height. It is equal to 1 centimeter cube. Or you can write it as 1 cc, that is centimeter cube. Now this 1 centimeter cube, it has the volume of 1 mil. This is also a point to remember. The volume of this 1 centimeter cube is equal to 1 mil. Now if we divide, you know that 1 centimeter, it is equal to 10 millimeter, 10 millimeter, 10 millimeter. So if we multiply this 10 millimeter multiplied by 10 millimeter multiplied by 10 millimeter, 1 mil into the millimeter cube, this volume, we can write 1000 millimeter cube over here. So number of spores in 1 mil will be this. So if we calculate, now after we calculate them, 5000 divided by 0.00025, it will be cancelled with it. What we will get is the number of spores, right? So 5, 1, 2, 3, 4, 5, 6, 7, 8. Right? Divided by 25. 1, 2, 3, 4, 5, 6, 7. So this will be the number of spores in 1 mil. You can write it 1, 2, 3, 4, 5, 6, 7. 2 multiplied by 10 raised to the power 7 spores